Thank you, Ola, for setting me up. Yeah, thanks for giving me the chance to speak to all of you guys. I hope I can put some interesting ideas in your eyes, into your head, although I'm not an expert on either of those topics. I'm not an expert in Kotlin. I've been using it for, I think, professionally for the last few months, and at home maybe from the alpha, but not all the time. And also the topic domain-specific languages is nothing I'm an expert at, but it's something that just catched my curiosity, and I used this chance to get into it myself and hopefully also get your attention on it. So let's get started. What is a domain-specific language? A domain-specific language is a computer language specialized to a particular application domain. So this doesn't say much more than the domain-specific language itself. That's probably also why this little elephant is so angry. And let's ask Wikipedia what a domain really is. And Wikipedia will tell you, well, a domain is a well-defined field of study that defines a set of common requirements, terminology, and functionality for any software program constructed to solve a problem. Wow, that's complicated. And our little elephant is still very angry. Wow, what's that? So it can actually be a lot more simple. I have a little definition myself that might still be a bit fuzzy, but it gives me, I think it feels a bit more accurate to me, which would be a domain is a well-defined area within a larger system with its own set of rules, processes, and terminology. Yeah, still fuzzy, but a little bit shorter and a little bit nicer, if you ask me. And let's put this in contrast to a general programming language, such as Kotlin or Java or whatever you've been using before Kotlin. We probably all, no one of us probably wants to go back. I've been enjoying Kotlin for sure. So a general purpose programming language is a programming language designed to be used for writing software in a wide variety of application domains. So this puts a huge contrast. What all of this will be about is defining a very specific domain. And the goal of that domain will be, in contrast to the general programming language, to get to be less comprehensive, much more expressive inside of the domain, and also it should exhibit minimal redundancy. And you can see the elephant is much more happy with all of this in mind. It doesn't need to be complicated. If it's complicated, well, it's usually bad, especially when you're sharing your code. So let's get rid of complexity and dive into the domain. And the domain I want to take you into today is probably one you pretty well know, at least from one end, and it will be about coffee making. So we will write a DSL that lets you describe the steps taken to create a specific coffee beverage. For example, I go to the cafe every morning and I order Americano because that's my favorite drink, and the barista just knows what to do, does all the steps to create this Americano, which is quite complex, as we will learn. So our domain will start behind the counter, where the barista is doing her magic to create my Americano. And inside of this domain, we will work with a few actions, such as pulling the coffee from the espresso machine, pouring liquids together, and objects we're going to work with are coffee blends, containers. You know, coffee doesn't hold in thin air, you have to drink it from a cup. And also about certain constraints, which are an important part of domain-specific languages. Those could be, in the coffee example, like an overflowing cup, a too high temperature, you know, you don't cook the milk when you pour it into the coffee, and also taste, of course. So, for a start, I went to Google and I Googled how do I make an Americano to get starting to design the interface for the example. And this is what Google gave me. You pull 3 ounces of espresso into a glass through the machine, and then you pour 3 ounces of hot water into a mug. And then you pour the espresso shot into the mug with the hot water, and you're done. That's Americano. Quite simple, or so you could think. Of course, there's always more to it. So let's try to formalize this a bit. Our operative words here are pull into, and the objects we are dealing with here are 3 ounces of espresso, which is pretty specific. I think an ounce is about 50 milliliters. And yeah, with these, we will get one step further. Now we identify entities, processes, and also constraints of our domain. Constraints would be the overflowing cup, for example. And we established a vocabulary for our DSL, which would be these steps taken, plain and simple. This is more or less what we would like to see in our domain-specific language, just these plain English sentences, which could be understood by a product manager or whoever is an expert in a certain domain inside of your business. Okay, so let's try to get to Kotlin finally. So this is how our syntax should look like. And to make this possible, we'll come to the first building block, which really helps us to get this going, which would be an extension function, or more specifically, an extension value in this case, which allows us to transform an integer into an ounce, which is one of our domain-specific objects here. And as you can see, this is pretty straightforward. As extension functions go, you specify the class name and then the function after the dot. And if you're working with values, you have to define this as a getter. And yeah, with just a single line of code, we are able to pretty simply express our 3 ounces without any obvious object creations without like getting the ounce class out ourselves. So another few very helpful building blocks are sealed classes, because they give us type-safe objects, which also help us in the implementation. When we use when expressions, we are forced to implement for each and every one of them. And inside of our domain-specific language, we will be able to use them just as they are, without any noise added. Another very useful part of it is an infix function, which enables us to define a function for a class and use it without any brackets and with empty spaces. So as odd as this last line looks, this is compilable Kotlin code, as the infix allows us a very natural syntax. Okay, let's go one step further and actually start to pull stuff out of our espresso machine. And for this, we need some sort of some sort of ongoing action, which we will represent by a data class. As you don't put the espresso just into the machine, we will use a Porter filter. This is the curious little thingy up there to the right. You've probably seen that before. This is where you put the coffee blend into, and this is what you hook into the machine and pull the espresso out of. So this will be what our pull function takes as an argument, and it will return an action which is sort of represents our ongoing process of pulling the coffee out of the machine. And here another aspect of the Kotlin language comes to mind that really helps us, because many domains, many not statically typed languages are used often for DSLs because they're quite flexible. But in Kotlin, we actually have our type safety and our flexible at the same time. And this really helps us because we can't actually, when using the interface, mess things up, and we can't put, for example, a muck into the pull function because it really takes a Porter filter, which is defined as a certain amount of espresso blend. Okay, now we only have one step left to actually come to a drinkable coffee beverage, which would be pulling the espresso into an actual container. And container, in my definition, are also a sealed class for a number of reasons. I usually prefer them over enums because they're just a little bit more flexible. And yeah, give you around about the same behavior. And now we finish our ongoing action by giving the pull function, the pull action, and another infix function which takes a container. And with this completes one step. And this single line of code is already like a very small DSL, which lets you use a portafilter to pull espresso out of the machine. Okay, what have we used so far? We used an extension function, or extension value more specifically, to find a convenient way to turn our integer into an ounce. And then we used an infix function to turn these 3 ounces to put them into a portafilter. And yeah, which holds 3 ounces of espresso blend. And for this espresso blend, we used a sealed class because it has less noise in this line. We have no dots, we have no brackets, and we can just use it as an object. And yeah, this looks pretty good already. Now we have to think about how we actually entry our DSL in our project or in any way. And for this, a very handy Kotlin feature comes to help, which would be function literals with receiver. And this is basically a function you pass in as a parameter, which is executed on a specific object. In our case, it would be the barista, an object of barista, which will hold all the functions we just defined, and will execute the given instructions on this object, which gives us this neat little entry point with a barista function, which takes a block, and inside of that block, you're in our domain-specific language, and you can use the keywords or the functions pull. To pull espresso out of the machine. Okay. Let's take a closer look at this. So, in order to define this, we give the function one parameter, which takes a class name and a dot with brackets. So, and then follows the normal function definition syntax. Probably a similar usage that I'm using a lot with Kotlin is functions as apply or let, which you make use of this specific feature. Okay, to get back to my favorite coffee beverage, let's wrap up the Americano and use our domain-specific language to do a bit more, which would be pulling 3 ounces of espresso into a glass, pouring 3 ounces of hot water into a mug, and then mix the two together also with a pour. And this is not much more than what we already did. We just added a new function pour, which starts a pour action, which also has an into function and is again type safe. And yeah, we have our own little first DSL. And it looks pretty, yeah, pretty good. I think it fulfills a lot of the criteria. One thing I would like to get rid of are the vals, of course, because they resemble sort of the GPL aspect of here. But I haven't found really a good way to get rid of those yet. If you have ideas, yeah, feel free to speak up or come to me after the talk. I'd be happy to hear it, and yeah, very interested if you guys can also contribute on that part. We had that one. So, and if we want to go beyond Americano and actually get also like maybe a coffee beverage with a little bit of milk in it, then we can extend a bit and steam milk. Let me just quickly check. Oh, there's a few duplications here. Okay, and here again, we just add on our barista a new function, steam, with the same pattern that we already applied. This time it takes a beverage, and we also have a new container, which would be a steaming pitcher. This is like a metal container which you use to steam up the milk that you pour into the espresso shot at the very end. And here we used another of these receiver functions, which holds two new functions, foamy and temperature. And there again, the infix is applied. Foamy and temperature are actually functions. And in this case, these are rules that you pass into the block, which make sure that that it will steam until the milk is actually foamy and has the right temperature. And this all of I have no bits of the definitions here because it actually follows all the patterns that we already used. So this is just more of an advanced example of the DSL, how you could use it. And yeah, if you would write this in a very general programming way, using the usual constructs, then this would have probably a lot of more lines, or at least some noise that takes you away from the domain of coffee brewing. Okay, let's write some tests and get constraints into the game. Let's start to write a unit test and verify that when you pull espresso into a too small container, that a certain exception is thrown. Now that we established our domain-specific language in terms of vocabulary, we actually make sure that all the regulations and constraints are in place when we actually implemented it. And on that end, we can also add another test for the actual taste of the coffee. And here we could imagine how maybe our end result looks like that's handed out of the DSL, which would be a beverage with certain flavors and a certain intensity, which will our implementation specify later on. And we would expect that if you just pour an espresso shot into a glass, that its flavor is rich and its intensity is pretty high, 10 out of 10. So yeah, testing. We've written our domain-specific interface. We write test, and then we can actually move on to implement it. You see a lot of to-dos here. This will be a little bit of work, I guess. But don't worry, Kotlin will help you. Yeah, you have the type safety of signatures, which will guide you. And you have sealed classes to ensure you won't forget anything when implementing. And may the data classes ease your way, because you easily can manipulate them and without manipulating objects. And yeah, so this is for you guys to figure out how to actually implement it. And there are many roads you can go down. But what you already established is that you have a domain-specific language which you can talk about with your domain experts or product people. And it's up to you to come up with creative ideas where to create those domains, because those can be really anything. Those can be rules applied on okay, let's take some businessy, what you usually don't like to hear, push messages. Why don't you write DSL to define which users should get push messages? This would be just one example to like give this maybe unwelcome task a little bit of taste. Yeah, thank you for listening. I hope I tinkled your brain a bit and you're getting some ideas. I think this also complements a bit the talk of Tassin and Toby. And yeah, I would take questions now.
Thank you. Let's make it 2 questions, okay?
Yeah. So water and hot milk in this example, are they blend? Like, are they instance of blend in this case?
No. No? I have an actual IntelliJ project for this, and they are both a liquid object.
Okay, but so it was defined on a blend,
yeah.
if I remember correctly. It's like if you do 3
yeah.
off,
yeah.
then
so pull only works with blend, and pour will work with a liquid. So this is a tricky part of building the domain. It's a very good question, because this is a tricky part of building the domain-specific language. When I was building up this example, I spent quite a lot of time of getting the domain-specific objects right. And you actually have to go a bit beyond the entities that live in the domain, at least on the implementation side, because there are things in between coffee and water. You have to like give it like some sort of higher abstraction in order to build these interfaces, and this is actually a huge part of it. Yeah.
So it's a bit more than was shown in the presentation.
Yeah, you're absolutely right. There's a bit more complexity in it. I think when I would open IntelliJ right now and go to all the classes and objects created, I would probably have like very short definitions, of course, but I would probably have like 10 or something. Yeah.
I think my question is quite similar. You had two espressos there, espresso instances. I think they are not of the same type, right? One is espresso in glass and one is espresso in mug.
Let me go back. Is it in the Americano or cappuccino?
I compared this one to the Americano one.
Ah, yeah.
Because they have the same name, but they are not of the same type.
So one confusing thing that that I have here is that espresso blend is actually like the powder of ground coffee, and what you pull out of the machine is also espresso. So I called the one blend to make a little distinction. And espresso is used, the espresso beverage itself is used for all the different coffees that you make. And so yeah, you will see the same property again and again. You could probably also take the already defined espresso shot and use it. But there's a small thing that's different that makes it worse to do the value espresso separately in each function, which would be that that's always a question which glass to take. In this case, you pour into a mug because a mug has a bigger size. I think I went over this too quickly, but
no, if you go back.
Yeah, wrong direction, I guess. Do I have the mug defined? I think it was just too far in the beginning and too short. Yeah, here, the glass has 3 ounces size, and later I use a mug because a mug is bigger, and I will pour something else into it.
No, what I meant, you have 2 times the name espresso, but
as a function and as a value inside?
No, if you compare cappuccino with Americano.
Ah, yeah. They both use
behind.
espresso as a basis. So this will probably be something that's repeated over and over again, yeah.
Gets too complicated. No.
Yeah, here's an Americano, here's a value espresso in a glass, and here in cappuccino it's into a mug. Because a mug is bigger and there comes the milk to it too. I hope we can also talk afterwards. Yeah, maybe I'm getting it wrong.
Thanks for the talk. Do you have any experiences writing the DSLs, both bottom up and top down, and trying to design the DSL in different manners? Does it change something? Like, for example, would you try to model functions as actions and parameters as nouns and things like this? Or actually, this way is much harder. You have to go, like, I don't know, from int, I have a nouns, and so on and so forth.
Yeah, I actually, this was actually my first go at a DSL. I just found the topic pretty exciting. And this was what came naturally to me. Maybe there's probably lots of other ways to approach this, especially when you go into testing frameworks, you see a lot of DSLs. And yeah, of course, also Gradle would be one example. But yeah, for Kotlin, this was a way to approach it that felt natural to me. Yeah.
One very last question. So who wants like really, really, really badly to ask the question? Like raise hand as much as possible. Like really hard. Okay. He was like doing this.
Thank you. The DSL helps you with making this very readable to other people and yeah, what he explained, but did you try or did you find anything that comes from the DSL that helps you to ensure that those actions are called in a specific order that help with the actual recipe? And anything that like helps with the business logic too, which comes from the DSL?
Yeah, I think this is a very good question. I think one part of it would be, or one way to go at it would be to define more exceptional cases when a certain sequence of actions comes that's invalid. So this would be one part that you could approach from the implementation side to assure it, that you first of all cover with tests. To have a compile time no-go, I wouldn't know. There's probably I wouldn't know if there's a way to approach it from this side. But for all the business rules and to apply them and enforce them, I would probably go back to exceptions and define tests. But type safety, I think, if you work with a lot of very specific types, that probably helps you to get a lot of the stuff out of the way. So yeah, I think you can get creative and even dive a bit deeper, maybe with more nesting of the brackets or whatever to really ensure that you have as little exceptions at runtime as yeah. So a short answer: no, I don't have a very good way for it, but there might be one. Cool. Thank you.